Okay, we are focused. Hi, everybody. I'm gonna come down and say hi. Hi. Okay. Um, what we're going to do. Okay, today we're going to simplify radicals. In your last couple of lessons, we solved quadratics with square roots. Okay, today we're not going to solve quadratics. We're going to learn a skill that's going to take us to the next level of solving quadratics with square roots. Okay, so take out your math notebook. Let's go ahead and get this started. First, we're going to start with a simple recall. Okay, recall perfect squares. Okay, perfect squares are 1 squared. Well, that's kind of boring. That's 1. We don't really even talk about it much, but we do know that 1 squared is 1, and so 1 is a perfect square. 2 squared is 4. That's a perfect square. 3 squared, 9. 4 squared, 16. 5 squared, 5 times 5 is 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. And it would keep on going, obviously. But we're going to stop there, okay? Now, these are our perfect squares right here. These are perfect squares because they are the square of an integer, okay? Now, so for example, we could write it the other way. The square root of 4 is 2. The square root of 9, that's a perfect square. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5, and so on. Okay? So that's first what I want you to keep in mind. Okay? Now, let's move on to simplifying radicals. So this is what's new. Okay? Number 1. If I want to simplify the square root of 50, 50 is not a perfect square. Okay, it's not on our list. What I want to do is break up 50s. I want to break up 50 as the product of a perfect square and another number. Okay, what I'm noticing is, 50 would land about right here on our list. Is 50 divisible by 49? No. Is it divisible by 36? No. Is it divisible by 25? It is. So I can split up the square root of 50 as the square root of 25 times the square root of 2. 25 times 2 is 50. 25 and 2 are both factors of 50. I chose 25 because 25 is a perfect square. So 25 times 2, that's the square root of 50. Now let's simplify. The square root of 25 is 5. And when I do that operation, I don't have the radical symbol anymore. The square root of 25 is 5, and I'm left with the square root of 2. The square root of 2 cannot be simplified because there are no factors of 2 that are perfect squares. The only factors of 2 are 1 and 2. Neither of those are a perfect square. This is the square root of 50 written as a simplified radical. So the directions are going to say write as a simplified radical, okay? Not a decimal approximation. Okay? We don't want a decimal approximation. This is an exact answer, 5 square root 2. Okay? Now let's do a few more of those. Okay, keep your list handy. In fact, I would recommend memorizing this list. Have this list memorized, this list of perfect squares. Okay, number 2. How about the square root of 27? Okay, now let me show you my thought process. There's a couple of thought processes I can use to simplify this radical. First of all, I know that if I get out my list of perfect squares, okay, 27 is right here between 25 and 36. 27 is not divisible by 25. It's not divisible by 16. It is divisible by 9. So I'm going to split up the square root of 27 as the square root of 9 and the square root of 3, because 9 times 3 is 27. Now, the square root of 9 is 3, and then I'm left with a root 3. Root 3 cannot be simplified, and so this is our final answer. The square root of 27 is 3 root 3. Okay? Let me go back here. I want to go back to number 1 to show you something. Okay? The square root of 50. Now, we know 50, we could also write as 5 times 10. 5 times 10 is 50. But that, using these two factors of 50, doesn't help me at all, because neither 5 nor 10 are perfect squares. So this doesn't really help. Not helpful. We want to split it up using a perfect square factor of 50. Okay? Which is 25. Okay, let's go back here. Number 3. How about the square root of 81? Okay, well, the square root of 81 is a perfect square. The square root of 81 is 9. So I don't have to split up 81. 81 is a perfect square, you get 9. Now you might be thinking, why don't we use plus or minus? Because when we solved quadratics, we used plus or minus. Okay? I'm going to tell you something. Use a little sticker here. When there's a variable in the equation, now how can I get this? Oh, there we go. How can I get this apart? This was supposed to be so much slicker. Okay. When there's a variable in the original equation, that's when you use plus or minus. Okay? If there's not a variable, if it's not an equation with a variable, you don't use plus or minus. You just say, okay, the square root of 81 is 9. You give what they call the principal square root. Okay? If they wanted the negative root, they would say the negative square root of 81, and then you would give negative 9. Okay? But if there's an x, if there's a variable in the equation, then you do the plus or minus. So when you're solving for x squared, plus or minus is the pair. Okay, let's say that again. When you're solving for x squared, plus or minus is the pair. I'm going to focus in on that. And we'll come back. Okay, there we go. Okay, number 4. So here's the thing. Let me just show you this. If you're solving for x squared, then plus or minus is the pair. For example, if I had x squared equals 81, and I take the square root of both sides, then I would need to say plus or minus 9. But if there's no x, you just give the root. Okay, number 4. I took a little side trip there, but that's some important stuff to keep in mind. Okay, number 4. How about the square root of 8? Okay, well, the square root of 8, I can simplify. The largest perfect square factor of 8 is 4. So I'm going to split that up as 4 times 2. The square root of 4 is 2. I'm left with root 2 that cannot be simplified, so the answer here is just 2 root 2. Okay, number 5. The square root of 24. Okay? Now I'm going to approach this one different, because this might be working for you, where you look at 24 and you figure out, okay, what is 24 divisible by? So you could say, okay, is 24 divisible by 16? 24 divided by 16? No. You get 1.5. Is 24 divisible by the next down perfect square? Is it divisible by 9? No. You get a long decimal. Is 24 divisible by 4? 24 divided by 4? It is. You get 6. So you're going to split this up as root 4 and root 6. The square root of 4 is 2, and you're left with root 6. Root 6 cannot be simplified because the only factors of 6 are 1 and 6, 2 and 3, none of which are perfect squares. Okay, now I'm going to show you another way to think of this. If you think of 24, the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. Okay, in my mind I was kind of thinking of, you know, the rainbow factorization, where you pair 1 and 24, 2 and 12, 3 and 8, 4 and 6. Those are our factors of 24. Okay, I'm looking for a factor of 24 that's a perfect square. Now we want the largest one. It's going to be helpful. 12 is not a perfect square. 8, not a perfect square. 6, not a perfect square. 4 is a perfect square. So we split it up as 4 times 6. The square root of 4 is 2, and I'm left with a root 6. Okay, number 6. Let's try the square root of 160. Okay? You might realize that 160 is divisible by 4. Okay? I'm going to show you something to point something out. You could say, hey, I know 160, that's divisible by 4. So 160 divided by 4 is 40. So you could split it up as 4 and 40. Now the square root of 4 is 2, and I'm left with root 40. This would not be completely simplified because the square root of 40 can be simplified further. 40 is also divisible by 4. So I have 2, just let that hang out there in the parking lot. Now the square root of 40 can be split up as 4 times 10, because 4 is a perfect square factor of 40. Now the square root of 4 is 2, and I still have this 2 out here. Notice this is all multiplication. There's no plus or minus going on here. There's no plus or anything, so this is all multiplication. I have the 2, the square root of 4 is 2, and I'm left with the root 10. Multiply these on the outside of the radical. 2 times 2 is 4, so you have 4 root 10. Now 10 is simplified because the only factors of 10 are 1 and 10, and 2 and 5. None of those factors are perfect squares. Okay, this is our final answer. Now this is the long path. Okay, working through it this way is the long path. Let me show you a shorter path. The square root of 160. Let's look for the largest perfect square factor. So if I look at 160, okay, first of all, is it divisible by 144? 160 divided by 144, no, it's not. Is it divisible by 121? No. Is it divisible by 100? No. By 81? Well, let's try it. 160 divided by 81. No. Is it divisible by 64? 160 divided by 64. Nope, you get 2.5. So it doesn't divide evenly into another integer. Is 160 divisible by 49? No. Is it divisible by 36? No. Is it divisible by 25? No. Is it divisible by 16? And you're probably already saying, yes, 16 times 10, and you're right. So 160 can be split up as 16 times 10. Now, we know the square root of 16, that's a perfect square. The square root of 16 is 4, and we're left with the root 10. Okay, if you look for, see how we got the same answer? If you look for the largest perfect square first, it's going to go right to it. So this is the shorter path. But If it's hard or if it's more challenging to find the largest perfect square, you could start with the smaller perfect squares, but then you have to keep going until it's simplified completely. To stop right here would be incorrect. That's not simplified completely. You have to keep going until it's simplified completely. Okay, let's just do a couple more, and I think you'll be good then. Okay, number 7. The square root of 180. Okay, well, let's just think about this. 180, let's do this, the rainbow tree. 1 and 180, 2 and 90, 3 and 60. 4, is 180 divisible by 4? Well, it is, it's 45. So 4 and 45. Ooh, I didn't leave myself enough room there. I'll write more factors down here. Is it divisible by 5? Yes, absolutely, because it ends in 0. So 180 divided by 5 is 36. So I'm splitting, we're going now, this goes in here. Is 180 divisible by 6? It is. You get 6 and 30. Okay, I'm going to stop here because I noticed right here that 36 is a perfect square. And if I look at my factors of 180, 180 is not a perfect square, 90 is not a perfect square, 60 not a perfect square, 45 not a perfect square, but 36 is a perfect square. So I can split this up as 36 and 5, because remember 36 times 5 was 180. Now the square root of 36 is 6, and I'm left with the root 5, and that's going to be our final answer, 6 root 5. So there's a couple of ways you can think about this, whatever your mind prefers, or you might switch it up a little bit. You could look and start taking 180 divided by our perfect squares, or you could write out the factors of 180 and then choose the largest perfect factor of 180 that's a perfect square. Okay, number 8. The square root of 263. Okay. Now this one, no matter which way you do it, you're going to find out it's not divisible by a perfect square. It has no perfect square factors. 263 is prime. That means the only factors of 263 are 1 and itself. So there's nothing to do here. Well, actually we did. We thought it through. That's what we did. But the answer is root 263. It cannot be simplified further. Any prime number cannot be simplified further. For example, we know that 13 is a prime number. That cannot be simplified further, and you just write root 13. Okay, I'm going to do one more. The square root of 245. Okay, maybe hit pause, try this one on your own, and then we'll regroup. Okay, how'd you do? Let's see if you got the answer. So 245, now that's a big number. 245, if I look at my factor tree, 1 and 245, it's not divisible by 2, it's not divisible by 3. I apologize, this is not a factor tree. I'm listing the factors of 245. It's not divisible by 3, 5, 6, 7, 8, 9, 10, 11, because the digits don't add up to a number that's divisible by 3. Oh, let's see. Is it divisible by 4? No, because it's not even. Is it divisible by 5? Yes, because it ends in a 5. So 245 divided by 5 is 49. How great is that? We got lucky there. So this splits up as 49 times 5. Well, the square root of 49 is 7. So my answer is 7 root 5. Okay, I think that's it. yeah, on Delta Math, what you're going to do is enter these two numbers. So you're going to enter 7, and then you're going to pull up the root key, and then you'll enter the 5. And that's how that'll work out. Okay. All right, that takes care of that. And I think we are done for this lesson. And work well. Okay. Bye-bye.